Yeah. I just typed in all of my calculus test grades yesterday, so now y'all are my next thing to grade. But all I know is the other pre-cal teacher said that hers weren't good. So then I just kind of didn't want to grade them, but I'll do it. I'll do it. Maybe I'll even start today, you know?
That would be good to start.
Oh. You would like that if I did that? Fine. When I start yapping, just tell me, go grade. Okay? Because I always take a good yap over grading.
I saw last year, and I said, I was like, debating how was you, your voice sounds so like,
You said that about your voice? You know, he has the girl.
the girlfriend.
Official. I can't, no, I can't tell you. But they're going to homecoming together. I also have never met her, so I don't really know anything. Uh-huh.
Who is it?
And she went to Westwood.
Wait, who is it?
I don't know. I haven't met her. Do you know who it is?
Does her name start with an N?
No.
What does it start with?
An A.
Okay.
Okay. Spill the tea after notes though. Okay. All right. So our notes today are gonna a little bit tie into factoring, but mainly what we're doing is we're gonna connect the factoring that we did last time to what the graphs look like today. So we have kind of some random terminology to cover. And hopefully your homework should be pretty quick that if you need to go back and do last time's homework, you can. All right. At the top. Okay, a zero is another term for an x-intercept. Okay, and then these are also going to be referred to as roots. Okay, reminder that we should not have computers out during this part of class. Let's close those up, put them to the side, please. Okay, so a zero, an x-intercept, and a root, those are all the same thing. Okay, so will you look on this graph and mark your x-intercepts? Okay, where do they happen at? Can you just tell me like the numbers? Okay, yeah, -7, where else? 1 and 5, great. Okay, so -7, 1 and 5. Okay, so if you are asked to find the zeros or the roots or the x-intercepts, that's what you're going to do is just look where it crosses the x-axis. Okay, positive intervals are going to be anywhere that your graph is above the x-axis or your f of x is greater than 0. So for this particular graph, I would say that it's positive or above the x-axis here to here and here to here. So now let's list those as intervals. Okay, we already did this on the very first day of school. Okay, where does my yellow section start? What x value is this? -7. And then where does it go under? At what number? 1. So it'd be -7 to 1. Okay, then I have another section where it's above the x-axis. That starts at 5. And then it stays above all the way to the end of the graph. So we would put 5 to infinity. Okay, now to connect multiple intervals, you're going to use a U. Okay, and that just means union, meaning you have more than one set. Okay, now if a positive interval is above the x-axis, then a negative interval would be below the x-axis. Okay, and that would be where your f of x is less than 0. So positive is above, negative is below. Okay, I'm going to highlight the sections that are below, then we'll write the interval for them. I have 1 here, and then I have 1 here. So let's do the little short one first. What's the start, stop? What numbers? 1 and 5. Okay, so let's put 1, 5. And then for my other section for this part, remember that you have to do start, then stop. So my start, if it's the far left end of the graph, you would say that's -infinity till -7. Okay, and remember, you can't list them in any order, you do have to follow. Okay, so minus infinity to minus 7. Okay, so positive intervals are above, negative intervals are below. There's one other type of thing you should be able to identify. That's increasing versus decreasing. So positive is above, increasing means it's going uphill. Okay, or the slope is positive. Now, these are not the same as the graph being positive. Positive means it's above the x-axis. Increasing means you have a positive slope. So on my graph, okay, I'm going to draw a little roller coaster. Okay, there you are, having the time of your life. Okay, if you're going uphill, that counts as increasing. So at the beginning of the roller coaster, are we going uphill? Yes or no? Yes, yes, till when? -4, right? That's where you would stop going uphill. So all of this part of the graph is uphill. Union. Then we have a little downhill part for the roller coaster. And then where does it start going uphill again? What x? 3. And then 3 till the end would be uphill. Okay? But notice the difference. Positive means above, increasing means uphill. Okay? Now, decreasing would just be the opposite. You need a negative slope and it needs to be downhill. And then we can see that in our little roller coaster problem, there's only one section that's downhill from here to here. So that'd be from -4 to 3. Okay? So a little bit of terminology there. Now let's label the graph at the bottom using those same 5 things. Okay, first thing I want you to identify are the zeros or the roots. Okay, remember this is where the graph crosses the x-axis. Where does it cross at? -3, -1, and 4. Okay, those are my x-intercepts. Next thing that I want to list is where f of x is greater than 0. That means above the x-axis. So I'm going to highlight all the sections that are above. So I have an above here, here, and here. Now, because this whole section pretty much stays above, we're just going to list that as one piece. Okay, you could break it up into 2 pieces if you want, but I'm just not going to. If this goes all the way to the left forever and ever and ever, that means negative infinity. Where does it stop at? -1. Okay, then do your little union. And then the other section of my graph that's above the x-axis would be from 4 to infinity to the right end. Okay? All right, the next thing we're looking for is f of x less than 0. My y's less than 0 will be found below the x-axis. And my graph is below the x-axis between what 2 numbers? Perfect, -1 to 4. Okay, and notice I don't need a union on that because I don't have another section that's below. It's just that one piece. Okay, then increasing means uphill, decreasing means downhill. Okay, so I'm going to put here, this is uphill, decreasing is downhill. Okay, and then if you're going to think of the roller coaster idea, remember your roller coaster has to start on this side. So as my roller coaster starts out, okay, it's going this way. Is your guy going uphill or downhill? Yeah. Downhill. So I'm only going to shade the uphills. So we're downhill, downhill, downhill till when? And then I'm uphill till -2. So I'm going to want that piece, -3 to -2. Okay, then I'm going to be downhill, 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 downhill all the way till, where does it bottom out at? What x? 1? And then it's uphill all the way pretty much to the end of the graph. So I'm going to put from 1 to infinity. Now it does kind of flatten out at 4, but then since it keeps going up, you can just go to infinity. Okay, that means the downhill sections of my graph are this piece and this piece. So I'm going to list this one first from -2 till 1. Okay, so from here to here, it's downhill. And then from here to -3. Remember, if you're talking about the left end of the graph, that would be -infinity to -3. Okay? -infinity to -3. Good on that? All right, turn the page. All right, the next thing that you should be able to do is identify end behavior. I think this is new for PreCal. I don't think you covered this in Algebra 1 or Algebra 2. Okay, but for end behavior, if you are talking about the left end of the graph, you're going to write x arrow -infinity. Okay, so on the left end of your graph, I want you to write as x goes to -infinity. If you are on the right end of the graph, you're going to let your x go to +infinity. So write that first. Okay, after you indicate which end you're looking at, you're going to tell which way the graph is pointed. So if your end is pointed up, you're going to let your y go to infinity. If your end is pointed down, you're going to do your y to a -infinity. So for this graph, which way are both of your ends pointed?
Up.
Then your y goes to infinity on both. Okay? All right, let's do the next graph. Okay, on the next one, they don't point the same way. So the first thing I want you to do is say what x is doing. If you're on the right end, your x is arrowed to infinity. If you're on the left end, your x arrows to -infinity. Okay, then y tells you which way that end is pointed. So let's do +infinity first. On the right end of my graph, which way is it pointed? Then you're going to put y arrow infinity. And what that means is that as my x's get bigger, my y's get bigger as well. Okay, on the left end, what are my y's doing? Down. So then you do y to -infinity. Okay. So really it's just kind of, it shouldn't be too hard, but just it's kind of a new symbol way to write it. Okay, one more left like that. Which way are both ends pointing on the third graph? Down. So then you would say as x arrow infinity, f of x arrows to -infinity. Now, y and f of x are used interchangeably on your homework. So if it's a y versus an f of x, there's no difference there. They're the same. Okay? But what this means is the right end is pointed down. Okay, now write the other side. What would I change? Yes? Is it going up though or down? So then we'd still put minus in it. Just change the x, correct. So this tells me my left end, and then this tells me that it still points down. Okay? All right, turn the page. Y'all are doing great. Yes, great, great. Okay, the next thing that we're going to very, very briefly talk about, okay, we have already talked about it before, is even versus odd. So if you remember, okay, even polynomials are going to have the same end behavior. Okay, and an even degree polynomial, your highest degree should be even. Now, I'm going to give you some examples of this so that you can draw them. Okay, if you have an even degree positive, okay, x squared is even. Okay, x to the fourth would be kind of like a W shape. Okay, that is also even. Okay, but the reason that those are considered even with a positive coefficient is because your ends are both pointed up. Okay? Now, if you have an even with a negative coefficient, okay, then both of your ends are going to point down. So give me a negative x squared and a negative x4. So if your highest power is even, your ends have to match. They're both up if you have a positive coefficient. They're both down if you have a negative coefficient. All right, now let's do odds. Okay, if you remember when we covered odd functions, we talked about your ends are the opposite. So fill in the blank here for an odd degree. Your highest power is odd and they have opposite end behavior. Okay, specifically what that means is that one end is going to be up, one end is going to be down. Okay, if you have an odd with a positive coefficient, overall, your roller coaster should be uphill. So it's going to start low and end high. So let's draw a couple examples of odd positive coefficients. Okay, we're going to do x and x to the 3. Now, x counts as odd because even though there's not a power written into it, what is the power? 1, and 1 counts as an odd. So that would be an uphill line. Versus x3 is still uphill, but it's a squiggle. Okay, but notice that both of those start at the bottom and they end at the top. Okay, can you guess then what a negative odd would be? It's going to start at the and end at the bottom. So these are going to start high and end low. So give yourself the same 2 examples, but just put negatives on them. So a negative x would be a downhill line. And a negative x cubed would be a downhill squiggle. Okay, but remember, your squiggle would start at the top and end at the bottom if it's a negative. Okay? So here's what we're going to do. Turn back 1 page. You have these 3 graphs. I want you to label which one's even or odd. Okay, go ahead and do that. Remember, even are together on the ends, pointed the same way. Odds are opposites. Okay, so let's look at the first one. Is it even or odd? Even, is it an even with a positive or an even with a negative coefficient? Even with the positive, write it down. Okay, we just went back 1 page if you're lost. Okay, this is an even degree because my ends go the same way, and it's a positive coefficient because both ends point up. Now, on this page, which one is even negative coefficient? The bottom one, very good. Because on the bottom graph, they both point the same way, but they both point down. Okay, so the first one is even degree positive. The last one is even degree negative. Okay, the middle graph, is it even or odd? Odd because the ends go opposite ways. Is it a positive or a negative coefficient? Positive because it starts low and it ends high. So that would be an odd degree with a positive coefficient. All right, stick with me. We're almost done. Okay, go ahead and skip to this page right here. Am I good to take this off?
Yeah.
All right, we're gonna skip number 2 and we're gonna get into where our factoring comes in. So will you take a look at this question right here? Okay, first thing that I want you to do is take your equation and you are going to set it equal to 0. Okay, and so what this does is this is going to find your zeros or your x-intercepts. Okay, now this is going to involve what we did last class. So take your equation, set it equal to 0. So I'm going to have 0 equals x squared plus 7x. Okay, last class, you learned 3 ways to factor. Let me remind you what they are. You learned the AC chart. You learned GCF. And you learned perfect squares. Okay, I'm going to put perfect square root. Ty, will you put your computer up, honey, please? Okay, these are the ways that we learned how to factor last class. So looking at the question that we're looking at, which of those methods would help me factor this? GCF is correct. Now remember, a GCF can be a number or a letter. What is it for this question? Okay, we can take out an x. Very good. So I'm going to put GCF divide by x. My x is going to come out. What is x squared going to leave me with? X. And then from the plus 7x, now it's just a plus 7. Okay, from here, whenever 2 things multiply to 0, that means one of them has to equal 0. So what you're going to do is you're going to take your equation and split it into 2 baby equations. You're going to let 0 equal x, and then you're going to let 0 equal x plus 7. Okay, and then you're just going to solve both of those little baby equations. Now, x equals 0 is done. How would I solve this one?
Minus 7.
Good. So 0 minus 7 is going to be negative 7. Okay, the answers that you just found are where this graph crosses the x-axis. Because remember, what is a 0? A 0 is an x-intercept. So give me a graph. Put a dot at 0. Put a dot at negative 7. 1, 2, 3, 4, 5, 6, 7. And then next question, what is the highest power on your x? Is it an even or an odd if it's an x squared? So x squared is an even function. And for the x squared, is it a positive or a negative on the x squared? It's a positive coefficient. Then that tells me that both ends are going to need to point up. Both ends are up. So go ahead and draw your graph in. Okay, it should be a U where both ends are up. Okay. All right, go ahead and turn the page. All right, take a look at number 5. First thing I want you to tell me is if it's even or odd. Okay, it is odd because what's the highest power? X to the. Okay, can we pause side conversations, please? Okay, we're not going to take that much longer, but we're in the middle of notes right now. So this is odd and it's a positive coefficient. That tells me that when I get to my graph, I'm going to start low, end high. Take your equation, set it equal to 0. Uh-huh. That is correct. The highest exponent. So if it had an x3 and an x2, you would still classify it as odd. Okay, then we're going to think about how we could factor that. What can I do first? Do they have anything in common? X. Okay, so I'm going to GCF and divide that x out. What's going to be left from an x3 if I pull an x out of it? Okay, and then out of my 9x, now it's just 9. Okay, this can break down again. What type? Is it a C chart or perfect squares? Perfect squares. So you're going to square root x squared. What's that going to break down into? Regular x. What's the square root of 9? Plus or minus 3. And then you're going to take each one of those and set them equal to 0 separately. So for the first one, I know my x is a 0. Then I'm going to let my x plus 3 equal 0. Then I'm going to let my x minus 3 equal 0. Now, let's identify a pattern real quick. If I had an x plus 3, how do I get rid of the plus 3? So my answer comes out to be a minus 3. That's always going to happen. Okay, and if my x was with a minus 3, how would I get rid of it here? I would have to plus it across. So basically, whatever your answer is, it should be the opposite of what was in the parentheses. Okay? So set up your graph. The answers that you found are where your graph crosses the x-axis. So my graph should cross the x-axis at 0, at 3, and -3. Additionally, I know that my graph is odd with a positive coefficient, so it needs to start low, and it's going to end high. So it's going to look like that. Okay, but how do I know that it starts at the bottom? Because it's a positive odd. Okay. All right, let's try the next one. Okay, first question, is it even or odd? Odd, but what's the coefficient type? On your odd, what kind of number is in front of it? A -2, so this is a negative coefficient. Okay, and if you don't remember, odd negatives are going to start at the top, end at the bottom. To find your x-intercepts, you're setting that equal to 0. So 0 equals -2x3 plus 10x. Okay, what should we do first? What type of factoring? GCF, what can I take out? A 2x. Now, if the front term is negative, you should take that out as well. So we're going to divide out a -2x. So my -2x comes out to the front. And I just need to put what's left over. So I had a -2x3. I took a -2x out. What's left? It was a 3. Now it's a 2 squared. Yep. And then for my 10 divided by -2, now this is a -5. Okay, from here, is 5 a perfect square root? No, but you can still factor it. Here's what you're going to do. You're going to break down the x squared into an x and an x. And then when you square root 5, if it's not like a nice pretty number, then you're just going to leave it as plus root 5 and minus root 5. Okay, but you can't actually get like a whole number because the square root of 5 is a decimal. So you just leave it just like that. Say that again. Because it's an x squared. And remember, in order to do this shortcut, not only do they both have to be square rootable, but you have to have a minus in the middle. So if it's a minus in the middle, you can do the split. Okay? But then just since I don't have a good square root for 5, I'm going to leave it in the house. Okay, from here, let's write our answers. Negative 2x needs to equal 0. X plus root 5 needs to equal 0. And x minus root 5 needs to equal 0. But then remember what we talked about, that if my x is with a minus root 5, what's the answer going to come out to be? A positive root 5. And if my x is with a positive root 5, what's that answer going to come out to be? Negative root 5. Now, let's talk about the 2x. Okay, if it's a negative 2x equal to 0, how do I get rid of the negative 2 from the front? Divide. But what is 0 divided by anything?
0.
Still 0. So here's the shortcut for that. If you have an x on the outside, 0 is the answer that goes. Even if there's a number with it, there's not a number. If the x is outside, 0 is your answer. Okay, draw your graph. Your graph should touch the x-axis at 0, at the positive square root of 5, and the negative square root of 5.
You just put it at 5.
We don't know exactly what it is, so I'm not even going to mark it. But the square root of 5 is a little bit bigger than 2. So it'd be like 2 point something. Okay, then from there, this is a negative odd. So where should it start? At the top. And then it's going to pass through the x-axis, through the x-axis, through the x-axis. Okay, because negative odds start high and end low. Okay? Ooh, we're done. Great. All right, so take out your computers. Okay, we're doing our delta math. And I'm just going to help you with one of them. And then y'all will have the rest of the class to go back and finish last time's homework if you need to. All right, your homework should be unhidden. If you got in it before me, you probably couldn't see it, but it should be unhidden now. Okay, the question that we're going to do together is going to be selecting equations from roots. And we're going to pick number, I guess we'll just do this one. This is the third of those. Okay. Now we're going to add more to this concept next week. So today's homework should be pretty easy. Okay, you have the picture. You're picking which equation matches. So can you tell me, this is the third of the select equations from graph. Where does this cross the x-axis? 0, which means an x on the outside. Where else? -2, then what should the parentheses say? X plus 2, because remember how they're always opposites? And then it also crosses at -4, then what should the other parentheses say?
X.
X plus 4. So looking at your answers, you want an X on the outside. The +2 gives me the -2. The +4 gives me the -4. Does that make sense? So you shouldn't have to factor any out today like we did in the notes. You will next time, but not today. Okay? And then if you didn't finish last time's homework, because I know that one was a little bit longer, use the extra time to get that done today. Okay? Good job.